Hi, this is No Squared again, and I would simply like to show you how the previous video works. Essentially, what code goes on behind the scenes that made everything work. Let's start with the test runner. Creates 10,000 rocks by using rand.nextInt. If the grid position isn't empty, then we simply continue. So in fact, it may create less than 10,000 rocks, and most of the time it will, but 10,000 or just about 10,000 is good enough. Then as long as for 80% we create a rock, for 15% we create a flower, and 5% we create gold, just using a random number, random float from math.random. We also create 1,000 box bugs in the same fashion. Let's take a look at box bug. Basically, we have bug. It extends bug. It has a function called checkState, which runs every frame on tick. CheckState checks if the current state of the bug has at least 2 effectors. If it doesn't have 2 effectors, it has less than 2 effectors, then it pushes 2 effectors onto the queue. It pushes a move effector that moves the side length, and it pushes a rotate effector that rotates 90 degrees. So every time that the bug moves side length units and rotates 90 degrees, it does that again, thus creating a box. Now what is this effector? Well, if we take a look at bug, we'll notice it goes to movable actor. So let's open movable actor. Movable actor extends actor, and it has a queue of movable effectors. Now on every tick, it checks if there's an effector on the queue, takes the top effector and ticks it. If it returns false, meaning it has finished, then we remove that effector, thus moving on to the next effector. If it returns true, then the effector is still in action and we simply leave it alone. Then we have our move effector, which moves a movable actor a certain distance, rotate effector, which rotates a movable actor a certain angle. We have kill effector. Kill effector is very simple. It simply takes the target and the time left, and once the time left reaches 0, then we kill the target. This allows for some very simple code that does very complex actions. For example, ZBug. ZBug in most implementations, especially the original grid world implementations, requires some sort of state machine. You would have to check, is amount of steps less than maximum steps divided by 3 or something like that. Then you would have to check for rotation, then rotate, and you would get a mess. It would be a mess. Now if we take a look at this stack based ZBug, we simply push 5 effectors. We have 1, 2, 3, 4, 5 effectors. The whole ZBug is accomplished in 5 lines, pretty much, all of the functionality. We move to the right side length. Notice that first we set the direction to the right. Then we move to the right side length, rotate 3 pi over 4 degrees clockwise. Then move side length times square root of 2 because it's diagonal. Rotate negative 3 pi over 4, so we align rightwards again. And then we move another side length. Once all of these effectors have been processed, then the ZBug has finished. Notice no conditionals, no explicit state machines. You simply push the effector and the bug executes them. For Gold Digger, we implement some more complicated things, such as AI. Gold Diggers search for gold and consume it. They use A-star pathfinding techniques to always find the shortest path. Only unmovable actors, such as rocks, can obstruct the path. Dynamic actors, such as bugs, are not considered in the search. If the Gold Digger encounters such an actor while executing its path, it will patiently wait. So it overrides AR.observable that can move onto. It can move onto gold and onto whatever its super actor can move onto. And it implements AR.observable by isValidMove. If the grid position is valid, then it might be a valid move. And as long as that grid position does not contain any rocks, then that grid position is a valid move, and we return true. So on tick, if we don't have a target, if we have a target but it's not alive, then get rid of that target. If target is null, then try to find a target. As long as we haven't found all the gold we need, and target isn't null, and path equals null, or the path that size equals 0, meaning we don't have a path, and we don't have any sort of state, then we construct a path. We call AI.constructPath from our position to the target position. And this is simply the AR.observable. Now if you take a look at AI, we have an A star implementation. Our heuristic is simply a weighted Manhattan distance, and construct path is a simple A star implementation. We use a priority queue for the open list, a hash set for the closed list, and if the candidate grid position equals the target grid position, then we construct a path and return that path. Otherwise, we return a no path. Other than that, most of the code is quite simple. That just about concludes this video. Thanks for watching and stay tuned.